Hi, so this is the part 2 on how to read laptop schematics. So in this video we're gonna see the laptop power sequence. As you can see, I'm going to explain to you all about laptop power sequence, and we're gonna see also the charge IC circuit where we have the power jack and the charge IC, as you can see. Okay, so I'm going also to explain to you the meaning and the purpose of this point in the motherboard. And I'm going also to teach you how to look for the datasheet of any IC in the internet. So we're gonna look for example, the datasheet of this IC and this IC. So let's get started. So here we have the adapter, as you can see. This is the adapter. So the 19 volt, let's assume that this is a 19 volt adapter. So the voltage or the 19 volt will go and pass directly to the switch. This is basically a switch FDS 6675. Okay, so if we go here, as you can see, this is the switch we're talking about. This is FDS 6675. Here we have the power jack or the adapter. So the 19 volt will pass through this inductor and goes directly to the switch. Okay, so after the adapter we have here a switch. Okay, and then we have here a current sense resistor. Basically this component, this current sense resistor, is designed to be melted when a certain current passes through it. So this is basically a protection component. It protects the whole motherboard from a high current. Okay, we can see that its purpose is just like a fuse. Okay, but the fuse protects the circuit from the current and from the voltage. But for this current sense resistor, it protects just the circuit from the current. Okay, here we have the charge IC. As you can see, we have its part number is BQ24703. So if we go here, as you can see, so this is the power jack. Here we have the switch, and over here we have the charge IC circuit. As you can see, we have BQ24703. So I'm going to show you how to look for the data sheet of this circuit in the internet. So we have the adapter, we have a switch here, we have a current sense resistor, and this is the charge IC. So once the 19 volt pass through this switch, it will goes directly here. Here we will get the plus V bat. This is basically the main power for, we will get the plus V bat. This is basically the main power for the motherboard. This power is about 19 volts. Okay, so this power will be distributed to the whole motherboard, as you can see, to all circuit in the motherboard. As you can see here, this arrow means this voltage will go to this IC, and then this IC will generate these voltages, will generate plus 5 volt, plus 3 volt always, and this also another plus 5 volt. Okay, but after receiving this signal, this is basically sleep S3. This is an enable signal. Okay, and then the same voltage will go to another IC. This IC has as a purpose to generate plus 2.5 volt for the VGA, for the graphic card. Okay, and then also, as you can see, we have another arrow here. The same voltage here will go, as you can see, to this IC. Okay, this is SC1470 in order to generate 1.5 volt. Okay, and then the same thing for this IC also to generate 1.8 volt. We have this arrow, means the 19 volt will be sent to this IC, and then this IC will generate 1.8 volt for the RAM. After, of course, receiving this enable signals. We have here 1.8 volt. This is the main power for the RAM. This power also will be applied to do another circuit or another IC, the TPS 51100. So this 1.8 volt will be received with this IC, and then this IC will generate 0.9 volt, the half of 1.8 volt. This is basically the VTT, because the RAM has two voltages. The main voltage, this is the main voltage, and the voltage for terminals, VTT. Okay? And of course, this voltage also, the 19 volt, will goes also directly to another IC. This IC also, as you can see, it will generate, after receiving 19 volt, it will generate plus VCCP. This voltage is about 1.05 volt. This voltage will be applied to the CPU, GMCH, and ICH. Okay? Of course, after receiving the enable signal, we have the power gate. And finally, the voltage will be also applied to the another circuit or another IC. This is basically the CPU or the processor power IC, as you can see. This IC is responsible to generate the VCC core for the CPU. So here we have the 19 volt, and also we have many signals, including power gate enable, including the voltage ID. VID means voltage ID. These signals basically are responsible to determine the exact voltage for the CPU. Okay, so this IC based on these IDs in order to generate the adequate VCC core. Okay, so here we have two channels. As you can see, we have the main channel, and this is the slave or the second channel. Okay, in this channel, of course, we're gonna find two MOSFETs, inductor and capacitors. Two MOSFETs here, inductor and capacitors, and here we have other control signals. So the voltage that we get here is distributed to all ICs in the motherboard. Okay, now let's go to this image. As you can see, so this point basically means the circuit. Let's assume that this is the switch. Here we have the 19 volt. This point, basically each point here, as you can see, means the 19 volt will go to a certain IC. This point means this IC, this first 19 volt. Here we have the second 19 volt for this IC, the third 19 volt, the fourth 19 volt, and so on. Okay, that's why we have this point here. Means this is 19 volt, this is another 19 volt, here another 19 volt. Means the voltage here is distributed to many circuit or ICs in the motherboard. Okay, so if we go also here, as you can see, here we have the DC jack. Okay, the 19 volt will goes directly to the switch, the FDS 6675. Okay, and then we will get here, as you can see, the VBAT. Do you see these pages? We have page 5, page 7, 8, 9, 10, and 35. Means the VBAT or the 19 volt will be distributed to the whole motherboard and will goes directly to these pages. In these pages, you're going to find these ICs. Okay, these ICs. Okay, so the 19 volts, after receiving the 19 volt here, it will be distributed to all ICs in the motherboard. This arrows, basically this arrows means this point here, okay, and means also this pages here. Okay, so after this IC receiving this voltage, it will generate these voltages. This also will generate these voltages and so on. Okay, here also for the charge IC also we called it the charge IC because also it has another purpose, is to charge the batteries. As you can see here we have battery, it charge also the batteries. So now let's see the schematic or the charge IC circuit. So here this is the power jack. After connecting the adapter, we will get here 19 volts. Okay, here in pin number 1, as you can see, we have 19 volts. Basically, these two pins, pin number 2 and number 3, and 4 and 5, all these pins are connected to the ground. So here we have 19 volts. This 19 volt will pass through these capacitors and through this inductor. Okay, basically here we have inductor. This inductor will increase the current. Okay, and then as you can see we will get here plus V adapter. Of course we will get 19 volt. So this 19 volt will go also and pass through a switch. We have Q501. This is a switch. Okay, this switch basically is a MOSFET. We have gate, drain and source. So this switch will generate here the same voltage, 19 volt, after receiving the control signal. The control signal basically, as you can see, we have gate, is coming from the charge IC. Okay, as you can see, we have here the AC drive. The AC drive, as you can see, this is, as you can see, this is the control signals. Okay, so after receiving the control signals, 19 volt will pass here to the source. Here we have the drain, 4 pins connected together. Here we have the source. So we're gonna get the 19 volt here. So the 19 volt will pass through 2 resistors here. This is basically other current sense resistors. And then we will get here the plus V bar. This plus V bar the same as this one here, the same as this one here. Okay, so this plus V bar will be distributed to many ICs in the motherboard. That's why we have this point here. So here this is the charge IC. So this part, okay, so this part here, just in order to get here the main voltage, a pure main voltage, 19 volt DC. Okay, and here this is the charge IC. Okay, so this part here basically is in order to generate the right voltage in order to charge the battery, So here we have, as you can see, a note high power trace. When you find this bolded line like this, means a high power trace. Here, for example, here, this is basically a high power trace, as you can see. This is a bolded line. This red line means this is all this is 19 volt. As you can see, here we have 19 volt. But these thin lines means control signals. Do you see, for example, this signal, for example, EC drive, this signal, as you can see, this is a thin signal. This is a control signal. It goes directly to the gate. This can be, for example, 2 volt, 5 volt, etc. But this one, this bolded line, is a high voltage, 19 volts, a high power trace, as you can see. Okay, so now I'm going to show you how to look for the datasheet of any IC of any component in the internet. So let's take, for example, these 2 ICs. This is the charge IC BQ24703, and we have here TPS 51020, to 3 volt, 5 volt control IC. Okay, so let's begin with this one, BQ24703. So we can just go to Google and then type BQ24703, As you can see here, we can just choose this one, BQ datasheet. So we get many results. Let's choose, of course, the first result. So here, as you can see, we have many part numbers, as you can see. So here, this is the part number that we look for, BQ24703. We have this PDF format. This 32p means 32 pages. And here we have the multi-chemistry battery charger, as you can see. This is a battery charger controller and system power selector. Why we call this system power selector? Because it selects between the adapter and the battery. When you connect the adapter, the laptop will work with the adapter. Okay, so when you connect the adapter, the laptop will work with the adapter. Okay, and when you remove the adapter, the battery will charge to generate this voltage. Okay, so when you connect the adapter will charge to generate this voltage. But if you remove the adapter, automatically the battery will take its place and generate this voltage. Okay, that's why this IC called, as you can see, system power selector. It selects between the adapter and the battery. So battery charger controller and system power selector. So let's click in the PDF format here. So here we have download. We can just click here. And here we go. We get the PDF file. We can just click this icon here in order to download the file. So here, battery charger controller. So this IC charge the battery and selects, as you can see, select between the battery and the adapter. So we have here the features, as you can see. Here we have description. The BQ24702 and BQ24703. Basically, these two has the same pinout and the same purpose. For example, if you have a bad IC with this part number, you can replace it with this part number, no problem. This IC is a highly integrated battery charge controller and selector. Okay, so basically you can find, as you can see, this IC in two formats, in this format, as you can see, and also in this. Okay, so here, as you can see, we have here the AC detect, the first pin AC detect. It detects if you connect the adapter or not. AC drive, here it generates, as you can see, the control signal in order to activate the switch. As we have here, we have EC drive goes directly here to this switch, to the gate of the switch, and then 90 volt will pass. Okay, so this is electrical characteristics. And over here, as you can see, this is the block diagram of these two ICs. This is the block diagram, means the inside of the IC. As you can see, we have the AC detect here. So inside the IC, we find all these components. For example, this flip-flop. This is amplifiers, as you can see. And we have mini logic gate. This is basically AND gate. These two are AND gates. We have here NOR gates. This is inverter. Here we have also resistors, etc. Okay, so this is basically the block diagram of this IC. If you want, I can explain to you and we can study the block diagram of this IC or any IC you want in a separate video. So if you want, you can just inform me in the comment below and I can of course explain to you this IC, all this stuff here, or any IC you want. Okay, so we have seen the datasheet of this IC, the charge IC. So let's now look for the datasheet of this IC. This is basically the 3 volt 5 volt controller. So we have TPS 51020. So we can just go here, okay, and type here, as you can see, this is the website, as you can see, alldatasheet.com. We can just type here to TPS, so 51020, and press enter. So let's see. So here we go. We have the TPS 51020. We have a PDF file with 27 pages, and here we have dual voltage mode, DDR selectable synchronous step-down controller for notebook system power. So let's click here in the PDF file, and then go here to download and click also here, and here we go. We have the PDF file, as you can see. Okay, so you can just go to this icon and click over it, and you can download it. So here, as you can see, we have the features, the description, as you can see. So here we have the applications, the notebook computer system, bus and input output, the DDR1 or DDR2 termination. So this IC normally should be the 3 volt and 5 volt controller, as we have here. Okay, so here we have TPS 51020. This is basically the 5 volt 3 volt controller. Okay, so let's see the datasheet again. So we have TPS 51020, dual voltage mode, DDR selectable. So we have the application DDR1, DDR2 termination. So this IC also could be used to generate the voltages for the RAM. Okay, anyway, here we have the electrical characteristics and using the same working principle. So let's see inside the IC the block diagram of the IC. As you can see, we have the functional block diagram. Okay, so this IC, as you can see here, this IC here, we have its block diagram here, as you can see. In the block diagram, you can find just the logic gates and the flip-flops. As you can see, we have gates here. Okay, all these are gates, logic gates, and we have flip-flops and amplifiers, as you can see. If you want, I can make a separate video where I can explain to you an IC, the block diagram of an IC in detail. So that's it, guys, for this video. So here now we are in the page number 5. So of course we're gonna see all these 68 pages, as you can see here. Now we are in page number 5. So tomorrow I will upload another video where we're gonna see other pages. We're gonna see basically these 68 pages one by one. Okay, thank you very much, and please don't forget to like the video and to share it if you like it.